this course in this semester is from information. So what is this? This is computer. So since we are majoring in computers and computer science, computer engineering, computer science and engineering, so we definitely deal with the computer to do something. Okay? So we need to apply the stuff. We need operating system. Operating system is a software. It's a set of bunch of software for what? Between user. User can be another computer or it's a human being. It doesn't matter. User and the computer. Okay. So we need operating system. On top of operating system, we are running database management system. That is another application. It's a program. Deal with what? Very large data. If you have a small amount of data, you don't have to use database. Okay? There are a bunch of other ways to deal with such a database. One of the nice way is memory-based database. Okay? For example, in your program language, your preferred program language, C++ or C language, you define integer I, integer j, or something object. Where are they? It's on the memory. When you compile, you will have the executable file consisting of a bunch of instructions. Then, when you run such a executable file, executable file object, what happens? Such an object, such a executable file will be loaded into the memory. Okay, then when the data that you assign, that you declare in your program is called, it will be loaded into the memory. Then in the memory, you can access the data, you can manipulate the data, you can manage the data. That's called the memory-based approach. Or sometimes you can create a file like the notepad. Actually, in my personal life, the most important information are in the notepad file, where I put all passwords. I cannot remember all the password and the link, and I don't want to be risky on my web browser or whatever. I create a small notepad file, then whenever I create the register or anything, I actually put everything. That's the one way. That's actually useful. That's much better than using Oracle database or other database. Because it's a small amount and easy to manipulate, I can modify it much faster than to use the DBMS system. Okay? But we are dealing with this very large data for the database system. So, can you put such an information directly into this, for example, Oracle database? No. Why? Computer can understand only structured data. Okay? Well, it's very simple. Our goal of the computer science, the computer objective with computer, in other words, data structure, everything I promise is a data structure. Okay? So we need to, even information has something structured, it's organized. Like somebody used the file folder like this, it's organized, but it's not data structure. Right? It's not 0 or 1 for computer. So we need to convert such a structure into the one that can be understood by computer. Okay? Directly? No, it's not that simple. So we need to start from logical modeling. Okay? This process is called the data modeling, database design. So it starts with something organized using diagram. This is called entity relationship modeling. Is that the only way to model the information to something database? No, this is just one example. We select the ER modeling to model information to some well-organized data, like the ER diagram. This is a logical model. This is a high-level model. At that time, you don't need any computer science skill yet. Okay? Then, this is still far from database system running on computer. So we need to do more job to model that like this. Relational model. Somebody already knows about such a relational model table, or this is called relation. Okay? Sometimes they are connected using foreign key. Each relation has something primary key. Primary key is unique and non-null, something like that. We learned about such a constraint, rule, policy, protocol. For what? Relational database model by Dr. E.F. Cole. Okay, this is one way to model the database. What else? Object-oriented model. If the database model is based on object-oriented model, this is called OO database model. If you consider network of entity network database model. If you consider hierarchical model, like we have a bank has the branch, and branch has the person has the account, and this one has the same structure, and access the data from top to bottom. This is called hierarchical database structure, which is still used in banking database. Yes. When I joined the bank, first time is 1965. At the time, it's almost 20 years ago. At the time, most of the banking database is based on this one. Then at the time, we downsized. From the centralized, this is mostly in the centralized database system. We downsized the system. It's called the downsize or client server environment. Okay? Yes?
What did you call it, migrate?
Migrate from this one to relational database?
Yeah, I think it was the IMS we were using.
Yeah, IMS. Right.
So why did you lift the mainframe environment to the IMS, which is running for 50 years?
Yes.
Go to the
Why?
server.
So, that's a good question. So still, IMS is used in banking system, and they are very good for security and reliable for the online transaction. The main problem is, so thanks to the power of the personal computer as well as internet connection, they like to do something in their job, but IMS and such a mainframe system is not flexible to support such a thing. Another big problem is, what if we have the 1,000 users? It works well for the 500 users. 1,000 users, we need to get rid of the old system and build the new system. It's very, very expensive. It's not flexible to add up such a thing. Build the database is scalable. Okay? And also very expensive. They're very expensive. You need to pay a lot more, 10 times more than such a relational database system. So we like to move from IMS, the hierarchical database, to relational database. Okay? So these are just the examples. There are many other databases, the model. So among them, we select this one by considering the benefit of this. So we can build the database finally using this model. There are fortunately software that is developed based on such a model. Also, there are software, DBMS, based on object-oriented database. There are software network database, like the IMS. There is a hierarchical database. We select this relational database model, relational database management system. We can create the database. Okay. Problem. The only problem is from here, ER model, logical model to database model. We do not. They intuitively, we believe they are quite similar, right? Some of the students already asked, is that the table or is that the relation? No, it's still entity, but they are quite similar. So we are going to learn today how to bridge the gap between ER model and relational database model. Okay, the main reason why we are selecting ER model for relational database is it's very similar. So it's a very easy. Actually, it's a step-by-step, straightforward way to convert ER model to relational model. If we can bridge the gap between ER model and relational database model, finally we can build a database, relational database system from information by conducting ER model or logical modeling. Then database modeling. There is a physical modeling part we will discuss later, second half of the semester, how to design the database by considering the separation of I/O or something like that. Then we can build a database application. Using the application, you can access the database. For example, if you are building the web interface, there is a web server, like the Apache or IIS, any database server. As a back end, this is a back end. So front end is, for example, I'm using JavaScript. From the JavaScript, you can request the data to the web server. Then web server access the database using database language. So we are focusing on this part, not front end part. Front end you already did in your programming class. Okay, that's the reason some of the students complain why we do not learn this front end part. It's your job, it's your responsibility. That's the reason we require prerequisite for this part. There are a bunch of different ways to access the data without using the application server or web server. You can access directly. You can build a standalone program using C++ or .NET, or you can use the web interface using PHP or other script language. Also, you can build a web interface using .NET environment, or you can use ASP. There are a bunch of. We cannot cover all this, but we will learn how to access the data from using sometimes the application, sometimes the tool, application tool like the C++. We will learn this part. And so I think that today a little bit discuss about this, and next 2 weeks. So today we will learn how to convert, how to map ER model to relational database model. Okay, this is the output of ER model, right? If we can convert this one is a company database. Can you remember this? You should keep your mind the diagram. Okay, then if we can make this relational database schema. Okay, this is called relational database schema that includes a number of relations with the name and primary key. Each relation must have one primary key, unlike entity. Okay? Also, there's a foreign key to represent the constraint, referential constraint. So each arrow represents, as I asked you the last time, end of last class, it's not a homework, so you can find the foreign key from the simple car sales database. Just like that, you can find the foreign key. So this is the output of today's class. So then, how can we do that? First, we are going to start from entity. As you can imagine, entity will be what? Entity, step 1. Entity will be relation. In other words, it will be table. That is the reason. Actually, one of the students answered when I asked what is this one? It's not entity. What? Table. Yes, that's true. Right. At that time, we didn't learn the concept of the relation, so I ignored that answer. Somebody asked, right? Right now, finally, we can understand why this will be relation. So entity of ER model will be the table relation in relational database schema. One more thing. This relation should have primary key, must. That's the rule, that's the constraint of the relational model. What about the entity? Entity sometimes does not. That's the weak entity. So we will consider weak entity later. In this case, this is a strong entity, which means at least one key. Then problem is, among keys, how can we select a primary? Primary key, how many primary keys? One. How many keys in the entity? One. How can you select? Randomly? It depends on what? Application analysis. Okay? It depends on. For example, in company database, so employee has a social security number as a key. Okay? Employee ID. Both of them are key. Each one will be better than other for primary key. Social security number? Both cannot be. You need to select one of them. If I were designer, I'd like to select an employee ID for company database. Why? Most of the application in the company, they are going to use probably employee ID to identify the employee. Right? Social security number is good for what? It's actually tax. Right? Social security number means it's a social security tax to get the benefit of social security from the government. Right? And it can be used for something identification of individual. Also, it's very important for financial status of each individual. So, if this system is for payroll or something tax related, SSN is better. However, when you investigate most of the application, they employee ID is no or good, better than this one to recognize employee. So that's the way of selecting the primary. It depends on the situation. And there is no general answer. Okay, sometimes it needs experience. Very hard to say whether this is better than this one, but based on your, or sometimes if the key is, for example, first name, last name, and middle name initial. Let's say this is the key, composite key. Suppose that this is a unique. So it can be primary key. However, this is too long. How many bytes? Sometimes 50 bytes. So when you sort the data, you need memory space or the additional space to sort the data, right? Ordering. How many sorting algorithms do you know? There are a bunch of other binary sorting, something. That needs additional space to the order, to make them order. Okay? That means if you have such a long size of the data, it requires more space and in terms of performance it's slower. So you'd better have shorter, also number. Eventually such a character string will be converted into the number using ASCII code. Right? So if you consider such a performance, sometimes instead of first name, last name, middle name, initial, you can create intentionally customer ID. Okay, that makes sense. So you can consider such an alternative way to increase the performance during the process, database design. Okay, so first step is mapping regular, the strong entity type is what? Relation, what? Table with the primary. That's the first. So, example, from this, employee. This is the employee. What is the key? Primary key. In this case, social security number is the only key, so no other way. SSN as the primary key and other. What is department? What is the primary key? Department number or name. So department number might be better than the name because of that reason. So the number. And project. Name or number, which one? Number. So P number. That's the primary key. And anything else? This is the weak entity. So that's it. Another important thing which is not mentioned in the textbook is naming. Okay? It can be A. No problem, you can create it. It can be 1. You can create it. But when you name the name of the attribute, name of relation, you'd better keep the meaning, semantic meaning of that object. Okay? Also, it's not a problem even though you create the number. Okay? However, you'd better put the something suffix to recognize which number which. Okay? You probably learn such a naming rule in your programming class. You don't have to follow such a strict rule. However, in database, you'd better keep such a naming rule. Also, most of the project manager have such a naming rule used in that project. So when you join the project first time, you'd better ask to the your project manager, what is the naming rule of this project? You'd better follow such a naming. Okay, that's it. The next step. The first step is a mapping regular entity. The next one is a weak entity. We have one weak entity over here. Okay. The problem of the weak entity is what? It does not have primary key. So, however, we have identifying relationship. Using that identifying relationship, we can borrow the key of this to make the partial key as the key. Okay? So, which means we can create relation. Then, partial key, that is the name plus social security number. And composite primary. So one primary key should be connected. Okay? That's it? Not new. One more thing. Where did you borrow this social security number? This social security number must exist in the employee. How can you represent such a constraint? Foreign key. So create the foreign key like this. Okay. So that's the weak entity. So the step 2 is the weak entity. I'm not going to. So step 2. Weak entity. It's a relation plus foreign key. Okay. The next step. Relationship. How many different types of relationship did we learn? One to one, one to many, many to many. So we are going to start from one to many. That's the straightforward, easy one. So, what is the example of one to many relationship? employee, many employees works for one department. That is many to one relationship. Also, one department control many projects. And supervisor, one supervisor supervising many employees, supervising. So how can we represent such a one-to-many relationship? You see? Relationship. Right? For example, the employee works for what? One department, right? So we can create a DNO as an attribute for referencing table as a referencing many sites. Works for department, one department. Which means the department number 1 should exist in department table. Department relationship. The relation. How can we represent foreign key? What else? Department supervisor SSN. Right? We create that one. That supervisor, not supervisor. It's a manager social security number. MGR. Anyway, that manager should be employed. So which means this one should exist here. Anything else? So project, department, control, many project, which means controlling department number should exist DPT. Anything else? Oh, supervisor. Supervisor SSN should exist in SSN 40 key. So using 40 key, we can solve the problem of one-to-many. It's so simple. But don't be confused. Many side and one side. Many side to one side. Many side is what? Referencing. One side is reference. Many of the students are confused in the evidence lecture. Okay? Don't be ignore such an importance. Okay, then next, one-to-one relationship. One-to-one relationship looks like a simple. What's the example of the one-to-one? I don't think manager is the one-to-many. There's a one manager for each department, right? So one-to-one relationship, I think we in the year, yes, one-to-one relationship here. Is there any other one-to-one? No. So one-to-one relationship. Let's take a look at the one-to-one. So we can use foreign key like this one, as we have used. That's one option. So one-to-one foreign key. The next option is actually, what does that mean, one-to-one? It's a one-to-one mapping. So think about your set theory knowledge. It's a one-to-one mapping. Which means, because it's a one-to-one mapping, you can combine, merge into one relation. Because it's a one-to-one mapping, you can merge. So, second option is merge. Third one is you can add new relation to represent this one-to-one, which means we have employee, we have department, we have, so like the manager relation. Then we have, each one should have the key, primary key. This is SSN. This is a DNO. And SSN, DNO is the primary key. Then create the foreign key. This is also possible because it's a one-to-one mapping. So you can add a new relation for one-to-one relationship. So create a new relation. There are three options. Which one is better than the other? How can you select one of them? It depends on the situation. What about this case? Foreign keys are better. Why? In this case, what about the third one, new relation? When do you select the third option? You have attribute. Or if you have a bunch of application to access, manager. Okay? At the time, it's better separate. What about the second? Merge. If employee and department are not different, quite similar. Also, if your application never accesses separately, employee, department, no. Most of our application access at the same time, both employee and department, you better merge into one. Okay, at the time you can select the second option. However, most of the case, one-to-one mapping can be converted into foreign key. Okay, using the foreign key. So we can create, in this case, we try to create the foreign key from department manager social security number to SSN. Good. Oh, we have one more. Many-to-many. Which one is the many-to-many? Workshop. We have one many-to-many of this one. Anyone who realized what happened during the first exercise lab, when you create the many-to-many relationship, anyone who realized something different? Yes. Yes, sir. And even though you create the many-to-many relationship, automatically create an entity. Okay? That means if you just create the foreign key only between employee and project, hard, actually impossible to identify who is who. Each employee works on each project. Okay? Because it's a many. One employee may works on many projects. Also, one project. How many employees? Many employees. So it's not easy, not possible to identify specific hours. So to address that one, we have cross-referencing in between table, just like what happened in our software. When you create the many-to-many, automatically there's an actual option. Just like whether you create the entity or not. So you can create the entity, so which means employee, the project, you can create the works on what is the primary key of this. Combining this one social security number and PN. Create the foreign key. One more thing is, most of case, many-to-many relationship has attribute. If not, if there's no attribute many-to-many, something wrong in your design. Okay? Think about it why. Most of case, many-to-many relationship has the attribute. That attribute can be here. Sometimes one-to-one relationship has the attribute, like this one, start date. How did we handle attribute of this? If we select this option, new relation, yes, we can add such an attribute to that. Merge, yes, we can add attribute to the merge. What about this case? In this case, because it's a one-to-one mapping, it can be either this one, it can be either this one. Because it's a one-to-one. Which way is better? Department or employee in this case?
Employee.
It's a department. Why?
The start date of managers on the department.
This is the start date of manager. So this is the look like using the Venn diagram. One-to-one mapping like this. Start date, if you create the attribute in employee start date, a lot of start date will be null data. Null does not means no space. Okay? To represent a null, you need space, something, symbol or something. Okay? Even though meaning is no existing. So it's a waste of space. So we'd better move this attribute of the one-to-one to one of the attribute. So it can be start date. What about this? This cannot be, hours cannot be here. Hours cannot be here. Instead, hours should be cross-reference table, in between table. Good. We almost done. So, one-to-one, one-to-many, many-to-many, already done. Multi-value. I mentioned this several times. Why multi-value is important? Yeah. So we have the multi-value here, location of department. Can you remember that? The value on the relation. Value on attribute in the relation. According to the relational database model, it should be atom, which means that there's no way to represent multi-value data. Because of that, we intentionally identify the multi-value attribute. Then how can we handle it? We need breakdown, which means creating new and table relation, location, department, location. What will be the key of department location? You should identify the DNO. DNO comes from here. And location. ID or name, it doesn't matter. If you have additional information, you can put it. However, this might be okay. So this is a multi-value. Others. Multi-value. We do not have an array. I will explain later. And okay, that's it. Let's compare with the answer of this one. So we have employed, we have department, we have project, we have dependent. Oh, I forgot works on. Works on is over there. Works on SSN and PNO hours. SN goes to here, PNO goes to here. Okay. And project D number, everything is fine. Okay? That's the output of mapping. So we have relational database schema. Then how can we use such a schema? You can create the database, relational database. Using what? Only Oracle? No, it doesn't matter. You can use any DBMS system that follow the relational model. Yes?
Wouldn't it be more efficient if we created a new entity for location, since we have location projects?
Okay, that's a good question.
Departments?
That's a good question. In terms of efficiency, is that the best solution? No. We will discuss later. So at the time, we need to consider normalization and denormalization. What is the normalization? What is denormalization? We will see later. Okay? Yeah, it's kind of enhancement in terms of performance. Enhancement means there are a bunch of other things, but we will consider performance speed. Okay? So we will see later. But this is just a general step to convert into relational model. But that doesn't mean this is the best solution. Sometimes it's a very subjective. We do not consider yet any application analysis. So in your real project, you need to consider. From time to time, I ask you what is the answer of what? The answer is depends on. Depending on this, you need to consider such a additional information like the application analysis or customer requirement. And the size of your data also even. Okay? So, but this is the general step of that. Okay? Very nice. N-array. What is the N-array relationship? We have one relationship but more than two entities are involved. For example, here, supplier supply a part to a project. The three of them are involved. There is no way to convert this one into this one. Foreign key can represent only two. It's a binary. Okay? There's no the constraint that can represent 3 or 4 tables are involved. So we can, as we discussed before, we can convert this one into this relationship, or we can convert either this, the ER model, and finally we can convert into database schema. Okay, yes?
That's the solution.
Yes, that's the solution. So you can create a new relation like this, or you can do this way. However, this is a little bit risky because you lose some information. That's the reason you'd better create a new relation most of the case. Okay? Then create a foreign key. Okay. So this is the output of supplier. This is the additional relation. What is the key of this? You can combine 1, 2, 3, 4 like this. If you don't like such a long primary key, you can add the primary key of this, like the supply ID. But you should be careful. Still, you need to keep such a constraint. Mostly such a additional key is sequence number. 1, 2, 3, 4. Like that. You probably use the last sequence number when you are doing the programming project with a simple database. This is huge issues actually. Sequence number. What is the sequence number? Index. You can use the sequence number as an index because this will be primary key. Primary key means unique, not null. So which means you can create 1, 2, 3, 4 like this. It looks like the simple, but it doesn't look. It does not. It's not very simple in real application. Why? First, how can you create the new number? You need to check the database, then last number, and add one, right? If you have a huge database, it takes a time to even check the number, right? Even though you check the number, so you get the new number, right? For example, in your database, currently 1 to 3. So you read the data, then next one is 4. Okay? Before you commit, you don't know what is commit yet. We will learn later. It's from the transaction. If you already took the operating system, what is a transaction? Yes, in operating system. How many of you? Yes. What's a transaction? You are taking now? You already took, right? What is a transaction? There's a problem of education. That's the final exam. Forget everything. Transaction is logical unit. Okay? It's an arithmetic. Okay? So you probably had a bunch of instructions, but that's not the basic unit of the processing. So you read the data from the memory and add up and write back to the memory. That is one transaction. Okay? So that transaction should be preserved until finalized. Finalizing of transaction means commit or abort. Commit means apply. Abort means go back to the original. I'd like to keep. So until commit, we are not sure whether foo will be inserted. So during the processing of transaction A, there is another transaction B to read the data, so it will get foo also. It may be possible. Right? Another problem is, yes, so I check, even it's not committed, there's another table to check the sequence number. So 4 is processing, so assign 5. But 4, unfortunately, 4 is a transaction A is aborted, which means 1, 2, 3, 5. There's a skip. So do you allow such a skip number? That's another issue. Okay? So some of the DBMS provide the function or object for sequence number. For example, Oracle. You can read the object name. It will return sequence number, next sequence number. But you should be careful. Also, what if we have something sequence number rule? What about the bank account? Bank account, actually using the bank account, you know bunch of information. Or the credit card number. Using the credit card number, you identify whether this is American Express or the Visa or this is the MasterCard, and or which bank or which financial group are involved, and something like that. You can get a bunch of information. So, can we consider such a meaning of the sequence number? So, sequence itself is a huge issue actually. But we are not going to consider that. But if we want add the sequence number instead of such a composite, the primary key, yes, possible, but be careful. Such issues. During my, when I worked for the bank, at the time we have actually sequence database. There are a bunch of sequence, some account number, branch number, something number, huge. So we have separate database to manage such a sequence. That's also possible. So this is a summary of the mapping from ER model to database schema. Okay. It's a good time to have pop-up quiz, but to test. But because of the last week missing class, so we do not have time. So I'm going to just summarize overview of the step. So entity type will be relation. Okay, one-to-one, one-to-many can be foreign key, a problem. But in case of the one-to-one, just in case, sometimes you need to merge, or sometimes you need to add additional relation. Okay. Many-to-many, you need to add the relation and two foreign key. Okay, an array, you need to convert into the binary relation and add new entity and new relation. Simple attribute will be the column in the informal definition, and composite attribute, the simple compound, is the same thing. Oh, what about this one? Address, string number, string name, and CD name, so on. Is there any way to represent this? No. It's not possible in relational model. Instead, you can create the attribute for each. Also, depending on, depends on the situation. Situation means application analysis. If your application access only entire address together, you don't have to separate. Okay? On the other hand, if your application access by seed, by state, by string, then at the time you can separate as an attribute. Okay? And multi-value, you can create a relation and for it. Domain actually is not popular in relational database management system. So you can, instead of domain, you can create a data type that will be discussed during the chapter 6 relational structured query languages. Chapter 4 and 5. We will talk about details about the data type. Key attribute will be primary key, and another thing is a secondary key. I do not explain about the secondary key. What is a secondary key? It's a secondary key. It's not primary. Okay? That's it. And what about the employee entity? For example, we have the SSN as a key and employee ID as a key. Two key, but we select the SSN, for example.